Alright guys, so this is the next section. For this section we're going to be proving two more theorems. The first one is proving the alternate interior angles theorem, and then we're going to talk about, it's not really a proof, but we're going to talk about why corresponding angles are congruent. So, for some definitions, and again we're just going to use these definitions in our proofs here. So for the transitive property of congruence, you pretty much have three segments or angles congruent to each other. So again, you have three sets of segments or three sets of angles, and all three of those angles or segments end up being congruent to each other. And the only way to do this is to have three separate statements. An example of this, and we'll go ahead and fill in the last part of this proof, are these three statements right here. So you can see in the proof they are three separate statements, but the first one we have angle 2 congruent to angle 6. Then we go on to say angle 4 congruent to angle 2. Notice how the angle 2 repeats. So another way to think about it, if 2 is equal to 6, 4 is also equal to 2, then you got 6 and 4 that are going to be congruent to each other. So it's just different combinations of these three angles, and again, you only have three different angles. You have angle 2, angle 4, angle 6. There's just three different ways of putting them together. And always when you use the transitive property, you're going to see those three separate statements together. And on the very last one, the third statement, that would be your transitive property of congruence. So we'll go ahead and fill that in down here. So transitive POC. And then the corresponding angles postulate, again, you have to have parallel lines. So given parallel lines, corresponding angles are congruent. And we're actually going to use this postulate in our proof. And remember that a postulate, you don't have to prove it. So we do have an explanation as to why corresponding angles are congruent, but it's not a proof that we're going to do. So given parallel lines, corresponding angles are congruent. So we'll go ahead and finish that up. And now we can use it in our proof. So if you look at your given, so we're given that these lines are parallel to each other. We have line L, we have line N. Angle 2 and angle 6, these are an example of corresponding angles. They're in the same location with regard to the parallel lines. For these four angles, this angle is, I guess we'll say it's off to the right side over here. If you look at these bottom four angles, angle 6 is also off to the right. So 2 and 6 are in the same location, they are corresponding. In the proof, we're going to say they're congruent. That is because of the corresponding angles postulate. And again, it's a two-column proof, so I'm going to abbreviate everything. And then if you look at angle 4 and angle 2, hopefully you can see these are vertical angles. We learned about that yesterday and we proved it, or today. So we can say angle 4 is congruent to angle 2. That is your vertical angle theorem. And then again, so the gist of the proof, what we're doing is, we know angle 2 is congruent to angle 6 because they're corresponding. Then we know angle 2 is also congruent to angle 4 because they are vertical. So if angle 2 is congruent to angle 6 and angle 2 is congruent to angle 4, these angles also have to be equal to each other. That's why we use the transitive property, and hopefully you can tell that angle 4 and angle 6, they are alternate interior angles. So we've proven that they are congruent. Scrolling on down, again, I'm just going to set up the equation for you. I'm hoping that you can solve for x on your own, either at home or tomorrow in class. So number 1 here, these angles are going to be corresponding, they're equal to each other. And there's only one way to set up the equations because we know alternate interior angles are equal and we know corresponding angles are equal. So every time you see these angles, when you're setting up the equation, you just put an equal sign in between the angles. Kind of like vertical angles from today. So something like this, you would have 31x plus 3 equals 32x plus 1. Solve for x and you're done. Over here, same concept. 91 plus x equals 85. They're equal to each other. solve for x. On the next page, and we'll do the relay race tomorrow as well. And then, yeah, so just more algebra problems. Just be careful, you know, number 7 kind of looks a little different here. These are not corresponding, they're not alternate interior. And you probably forgot, but these are what we call same side interior. These are going to be supplementary. So the way that you would set this one up, you have x plus 70 plus x plus 120 equals 180. And we'll make a note here, these are same side interior. And they are equal to 180. Alright, so short video, one that even Sammy can watch. I'll see you guys tomorrow.